Welcome to our class meeting video for day 2 of our study of acids and bases. Now you can see here that we've just got 2 pages of notes to cover, and what we'll do is we'll give you an overview of some of the definitions that we want you to learn. These definitions come from a website that's linked to Classroom, so you want to look at that as part of today's work. And I think on Classroom I list the particular definitions that we're most interested in. So we want to have a little bit of a discussion on that. And then we're going to do something called a neutralization reaction, which is part of a unit on acids and bases. We'll learn that acids and bases neutralize one another to create what's called a salt and water. And then a little bit of an introduction to the pH scale, which probably most students coming into chemistry have heard of the pH scale, and maybe you monitor pHs in a swimming pool, but we want to put a little bit of a chemistry perspective on it. Okay, so back to our first notes. I've only screenshot some of the definitions that come from this website, and I would characterize these into the somewhat familiar from day 1 and the a little less familiar part of day 2. So in the top part, we learned what acids are and acidic solutions are, and we've got our favorite example there, which is hydrochloric acid. And you've done this in the practice from day 1. You've taken molecules of hydrogen chloride. So we're reminding ourselves that these are 2 nonmetals. So they actually covalently bond. And I'll just do a Lewis structure up here. If we were just looking at the pure substance, I'm trying to do my valence electrons there. And you won't have to know this to this detail for this unit, but just trying to remind you, these are 2 nonmetals, so when they do form a compound, we expect that they share electrons to make a covalent bond. However, what's interesting and part of the intrigue of some of these acids is that while they're molecular in the pure substance solid form, once you put them in water, then the ions form. So in this case, if we take a molecule of hydrogen chloride, or we could call it hydrochloric acid, even as the solid. If we put it in water, then we make an acidic solution. We're forming the hydrogen ion H+ and the chloride ion Cl-. And what's definitional to the acid is that one of the ions that we're making is the hydrogen ion. Okay, and as an early introduction to pHs, the so-called neutral pH is pH 7. And so acidic solutions have pH values that are less than 7. So we're going to start to gain a little bit of familiarity with that. Okay, then we have the neutralization reaction, which we'll look at on page 2 of our notes. So this gives us a little bit of a preview and a definitions preview. So the unit is called acids and bases, right? So we've talked a little bit about acids. Now we want to talk a little bit about what a base is. A base, by definition, is a substance that reacts with an acid to form, and we'll do this mostly on the next page. It forms a salt, which is synonymous with an ionic compound. And we're very familiar with ionic compounds. We just don't call them salts that much. Ionic compounds probably isn't going to come out looking very good. Yikes. Okay. So salt and ionic compound are synonymous. You think about table salt, NaCl. Mostly in class we talk about, and I'll just say example, NaCl. So in our chemistry classroom, we've been identifying that as an ionic compound. We could have been calling it a salt as well. All right, coming back to the main mission here, a base by definition is a substance that reacts with an acid to form this ionic compound or salt in water. We'll see that on the next page. I'm less concerned with this statement here. It's not that it doesn't come into the content, but I don't think you need to know it from a definition / description extent. So let's just focus on the definition of a base in that first sentence. If you have a substance that's a base, and it also happens to be soluble in water, so if you can dissolve that base in water to separate those ions in the water, then that's called an alkali. And when you go through that process, you create an alkaline solution. Just as from the day 1 content, we talked about substances. I'm going to scroll up here. Substances that are sources of hydrogen ions are called acids. And when you go through the process of putting it in water to form that ion H+, along with an anion. You call that an acidic solution. So acid is to acidic solutions as alkalis are to alkaline solutions. The term base comes from the fact that it can react with an acid to form a salt. All right, I don't think I've been super clear on that, but hopefully it will evolve over the day in the unit. So in this bottom part, very quickly, we can have bases that are not soluble in water, so therefore we can't call them alkalis. And then we have bases that are soluble, that do dissolve in water, that are soluble in water, so therefore we can call them alkalis. All right, let's take a look at the neutralization reaction on page 2. All right, so here's an acidic solution. Let's neutralize it. This should look somewhat familiar to you. I've made the quote beaker of water a little wider so I can draw in it. But what we've done here is we've taken hydrochloric acid and we've dissolved it in water to make an acidic solution. So this currently is an acidic solution. And what we want to do is we want to practice this idea of neutralizing it. So what I'm going to pick to neutralize it, on the previous page I was given 2 bases, one of which was soluble in water. That was the sodium hydroxide. So let's neutralize it with NaCl. NaOH. Okay. So I can take this base and I could make an alkaline solution by dissolving it in water. And I have to know a little bit about what those ions form. The ions form when I do dissolve that in water. One of them is Na+, and the other is OH-. Now, we didn't focus too much on polyatomic ions. We would give you a list of them during tests sometimes, so I've got to be sensitive to that during this test. But the very familiar sodium hydroxide, I think students should know well. When a unit of that gets dissolved in water, you have Na+ and OH- ions. So I'm looking to neutralize the acid. The acid, I'm calling this an acid because of the presence of the excess H+. So I'm going to drop some sodium hydroxide in here. And the first unit that I drop in, the ions separate, and I'm just kind of drawing them random and a little bit slanted maybe. And so what I'm going to see now is that, I'm going to change pens, as I add the base, right, the acid reacts with the base to form a salt and water. Well, here's my water forming here, right here. If you put an H+ next to an OH-, those combine to make a water molecule. And as I look at this, I still have excess H+. This is still an acidic solution. So I'm going to drop another Na+, OH-. I'm now going to put a second unit of sodium hydroxide in the water. And there again, now the process of neutralizing is to reduce the concentration of the H+ in the water, because the H+ is what makes it an acid. So I'm going to recognize here that now I've added a hydroxide ion, the OH-, and that can combine with the hydrogen ion to make another water molecule. So let me scroll down a little bit. So as I make the water molecules are not drawn. That just gets in the way of the overall characterization of the solution. So what I have here then is I have Na+, and I have a Cl- that was there originally. I have another Na+, and of course these are moving around in the water solution. They're not statically located. But what I've got now is salty water. This is table salt that's dissolved in water. If I heated this up, if I boiled the water off, I'd get the salt remaining in the container, and I think we did that in one of our labs. So I'm nearing my 10 minutes, so I'm going to want to wrap this up pretty quickly. But in day 2, you will be exposed to the terms base, alkali, alkaline solution. You will consider the neutralization reaction, and we also want you to get introduced a little bit to the pH scale. So 7 is the neutral pH, and then pHs less than 7 are called acidic solutions. And if you have a pH greater than 7, then that's indicating that you have an alkali solution, which is a large presence of OH minus ions, hydroxide ions. All right, I'm on 10 minutes. I got to call it good. Thank you.